Okay, so in this video, we're going to try and get the fan to be driven by a motor at a specific speed. So, like usual, we're going to start with our equivalent motor. So here is the voltage that we're trying to find. Here is our resistance right here. We're not going to worry about our inductance because we're going to be going too slow for that to really matter. And then we have our back EMF, which is right here, 0.0668 omega, and then we come across here. Now, the other equation that we have is we have our torque is equal to our KTI, which is equal to, that's this one right here, 0.066 I. Now what we need to do is we just need to figure out what our omega is. So we need to get our omega and the I that we need. So we start with our omega which is right here. And then, so we want 1,000 RPMs. So we're going to say omega is equal to 1,000 times 2 pi over 60, which is equal to which is equal to 104.7 radians per second. So then the next thing that we need is we need to get our torque. So our torque we're going to grab from this equation here. And so we have our torque is equal to 7 times 10 to the minus 4 times 104.7 squared. Which is equal to 7.67 Newton meters. So then we just have to plug in this torque into this equation here in order to get our current. So now we have the current that we need is equal to our torque, 7.67, divided by our torque coefficient, which is 0.066. So that becomes 116.2 amps. So now our current, we're going to go back to our circuit to get our current. So then we have that I is going to be equal to VA minus KE omega divided by 0.3. So we have 116.2 is equal to VA minus our KE, which is 0.0668, times our omega, which is our 104.7, divided by the 0.3. And so then we just solve that for VA, and our VA equals, so our VA equals 41.85 volts, and then we are done with our problem.